Alrighty. So I'm gonna see if I can try to do this way. I originally made a recording with my phone, and me doing this on paper, and now my phone's being really difficult about uploading it. So we're gonna try to do this way. Alright, so for this first problem, we're given a lot of really good information. Namely that, right, we've got, well, you can't see me point, so I'll use my mouse. We've got 9.11 milliliters of this 0.106 molar sodium hydroxide solution, right? And that's how much it takes to titrate yeah, no, acetylsalicylic, acetyl, acetylsalicylic. Acetylsalicylic, there we go. Wow, I should know how to say that too. Um, acid in a tablet of aspirin. And we're given the molar weight here, right? Okay, cool. Now, quick thing we want to figure out first, right? Or no, I lied. We'll come back to that actually. Let's come over here and let's get some stuff knocked out, right? So we've got 9.11. Let's make this a little bit bigger here. All right, 9.11 milliliters. Okay, of this sodium hydroxide solution, right? Okay, and we're gonna go ahead and actually make that boop. There we go. All right, cool. Let's do that this way. And I'm actually gonna bonk this into a do you mind? There we go, a table. All right. X, plonk that in there. Delightful. Okay. Right, this solution here, okay? And then we're gonna insert a to the right here. Okay, now we also know our molarity, or our the concentration, right? So 1.06 moles of sodium hydroxide per 1,000 milliliters of sodium hydroxide solution. All right. And yes, technically a molar, right, that molar concentration is moles over liters, but a liter is 1,000 milliliters, right? Cool. Great. All right. So that's all well and good, right? Okay, that tells us how many moles we're gonna have, right? You're gonna do that. Okay, cool, great. All right, so now let's put another column in. Okay, here's what we're gonna jump back over here, right? Because we need to get these, how many milligrams, right, of acetylsalicylic acid are in the tablet, right? So this is great, but how do we get to here? Well, the first thing we need to do is determine what the ratio of moles of sodium hydroxide to, sodium hydroxide to acetylsalicylic acid is going to be. And if we look at this half reaction here, we can see, right, we have one hydrogen that's going to take off from the rest of this, and it's going to hang out with that hydroxide, which is coming from the sodium hydroxide, right? And it's going to make a water, right? Okay, so 1 to 1, right? 1 water. Cool. So that means it's going to take let me put this in the right place here. It's going to take 1 mole of, yes, 1 mole of sodium hydroxide to get us 1 mole of, or it'll be equivalent to 1 mole of, and I'm not writing out acetylsalicylic acid, so we're just going to write acet. Okay? Cool, great. All right, now let's get another column in here, column to the right. Cool, so now we know how many moles we have, right? Well, now we need milligrams, right? Well, we were given that molar weight, right? And that's very, very convenient because then I can just type that in here. 180 grams of acetylsalicylic, I can't type, acid per mole of, don't do here, 1 mole of acetylsalicylic acid, okay? So that gives us how many grams? We need milligrams, right? So we can plonk that into the right as well, right? It's going to be 1,000 milligrams to the gram. I hope that's not revolutionary to anybody, okay? Plonk that down one more size so it's nice and lined up. Okay, cool. All right, so now that, excuse me, now that we've got that, right, go ahead, you can cancel out units, right? So, that cancels with that guy. Magic, right? Please strike through. There we go. This will cancel with this guy. That'll cancel with that guy, right? Because this is one big division bar, essentially. And then we can cancel out the grams here, right? All right, cool. And one other thing we can cancel out is we have 1,000 up here and 1,000 down here as well. Let's just, oh, come on. There, no. All right, come on. Maybe. Okay, it doesn't want to cooperate. Great. All right. Anywho, moral of story, right? Go ahead and you can cancel those out. All right. Now, now that you've done that, right, that leaves us with milligrams of acetylsalicylic acid, and that's going to equal that 174, and then there will be a decimal, but we don't care because we only have 3 significant figures, right? So milligrams of acetylsalicylic acid, okay? Per tablet if you really want to get into the weeds, but you're only going to type in the 174. Okay, great. All right, on to our next guy. Get our table in here. And I'm just going to preemptively create as many columns as I need. All right, so let's go talk about this guy here. This guy's going to be a little different. Mostly the same idea, though. Okay, right? So tells us our molar concentration of the sodium hydroxide, how much of the sodium hydroxide. But instead of telling us the concentration of the, right, instead of telling us this, the molar weight, it's going to tell us how much we titrated, right? And it wants to know what's the weight-to-weight percent of the acetic acid in the vinegar. And actually, quick side note here, right? Weight-to-weight percent is going to equal the, the weight of the solute, right, over the weight of the solution, right? So the thing we're dissolving inside the whole thing, okay? Cool. So let's just go for it, right? 44.00 milliliters sodium hydroxide solution, right? Okay. And then we have 0.0989 moles of, and this, right, this looks pretty much the same, right? Moles of sodium hydroxide over 1,000 milliliters sodium hydroxide solution. All right, bingo bango, pretty simple, right? All right, and then we have to do the same thing. We have to determine what the ratio is of the moles. So we're going to do that. Look at that. 1 to 1 gives us 1 water. Cool. All right, so 1 mole of, in this case, acetic acid over 1 mole of that sodium hydroxide, okay? So how do we get this then, right? How do we convert to a weight? Well, we're given the molar mass, which, guess what? Is essentially the same thing, right? If the molar mass of acetic acid is 60.04 grams, that means 1 mole equals 60.04 grams, and you can convert that into a ratio nice and easy, right? Just move it over. And Wow. I mean, that was magic. All right, cool. Now, we have this, right? So we know how many grams of acetic acid we have, so we're good on that front, right? That's what we want, right? That's that weight on top, right? Now we need the solution's weight, and we're told this titrated 5 milliliters of vinegar, right? Which is our solution, right? That's what the acetic acid is in the vinegar. Okay, great. Well, how do we get a mass out of that? Well, we're told to assume the density is 1 gram per milliliter. So guess what? Milliliter, right? 1 gram vinegar. All right, and now we're gonna go ahead. We're gonna cancel our milliliters there. We can cancel our moles of acetic acid. We can cancel our moles of sodium hydroxide, and we can cancel our milliliters of sodium hydroxide solution. Unfortunately, we don't get to cancel this 1,000 here. It would be nice if we could, but we can't, right? So, right, plug all that in, and you're going to get a number that looks like 5.22, I think, like 47, and then some other stuff, right? And that's going to be grams. Acetic acid per gram vinegar. Okay, well, go ahead and just, you're going to multiply that by 100 because we want a percent, right? Or I'm sorry, excuse me. Good Lord. It's going to be 0.052247, whatever, okay. Well, multiply that by 100 to give us our percent, right? So 55.25%. And why do I say 0.25? Well, we have 4 sig figs, right? 4 sig figs. Yeah. So just, yeah, go with that. Beautiful, nice and easy. Okay, great. And your answer is going to be this, just without the percent sign, because Candace is going to yell at you for that. So, yeah, if you have any questions, yeah, I'll answer them as best I can.